welcome back to my YouTube channel, and today I'm up with the next question of top 150 interview questions of lead code. So let's get started with today's question. So in this question we have to find the index of the first occurrence in a string. We are given two strings, needle and haystack. We have to return the index of the first occurrence of needle in haystack, or -1 if needle is not part of haystack. And let's discuss the constraints of the same. So we are given that the length of the haystack and needle is not more than 10 raised to power 4, and both of the strings consist of only lowercase English characters. So let's discuss the intuition behind this question. So before moving, so we are given a string lead code, and we have to find the substring's first occurrence index, right? So where does this substring occur in this string? It occurs at fourth index, right? And we have to return 4 as our answer. So I think this question is really simple. What we can do, we can apply two for loops, okay? One which is running from 1 to n, and the other in which we have to find from that index I till needle dot size, that whether all of my elements match in this substring or not, right? And if my number of elements matches, then I will simply return my answer, else I will not. So this is one of the solution. So instead of using two for loops, I think we can do one more solution to it. We can use an inbuilt function which is substring, which will actually obtain a string of size. We will actually take a string of size s, and we will apply a function substring on haystack, and then we will be moving from I till needle dot size. And if my s equals needle, I will simply return that I, else I will be returning -1. That's what I have to do in this question simply. And yeah, one more limitation to this question is that suppose if I get a needle value as empty, so what would be my answer in that case? So in that case my answer would be 0, because in a string there always exists a empty string, and existence of empty string is none or less equal to 0. So this is the possible solution that we can actually do. So why I have and this is the optimal solution for this question, right? Why so? Because the lengths of the string, that is haystack and needle's length, is always less than or equal to 10 raised to power 4, and computing this operation and the time complexity in which it's operating, this solution which we have discussed is operating, is O of n into m. And at max what could happen, that we are getting 10 raised to power 4 as length of haystack and 10 raised to power 4 as length of needle. So our time complexity will still be in 10 raised to power 8, and we can perform 10 raised to power 8 operations at a time, and it's easy for us to do. So that's why I preferred using this brute force method in this question, although we could have used KMP algorithm as well. But for such an easy question and for very shorter constraints, I don't think the use of such an algorithm actually makes sense. But I will discuss the KMP algorithm in some other video using the same question. But for the time being, this is the only solution that is worthy for this question. So let's discuss the code for the same. So yeah, let's move to the code. So what I have done, I have simply checked if my needle dot size is equal to 0, and if my needle is greater than my haystack size. So why I'm doing this comparison, because suppose if I have to find a substring which is greater than the size of the string, how will I actually find? I have to return the -1. And now what I will do, I will simply check for each and every index till my needle dot size, that if I get a substring which is equal to my needle, I'll simply return that index, otherwise I'll be returning -1. So now let's run this code. It's pretty simple. And for other languages also you can implement that substring function if you wished so, but since I'm working in C++, so rather than using that another for loop, I have preferred using a substring function because it has actually reduced my code, the amount of code that I have to write. Okay, so now let's submit this solution. And yeah, if you want, we can analyze the time complexity of this. It turns out to be n into m, approximate near about n square. And now let's analyze the space complexity. It turns out to be of 1 because we are not using any extra space in this. Okay, so I hope guys you have liked the way, if you have understood this question, please do hit the like button on the video and subscribe my channel if you are new to it. And please do share it with your friends if you feel it's really worth. And why I'm saying that, not an issue. But if you want to connect with me on topics other than these DSA questions, please do connect with me on platforms mentioned in the description. So thanks and keep watching my videos.